Hello everyone, welcome back to the channel. In this video, we will be discussing Newton laws. There are three Newton laws. So friends, let us discuss. Newton's laws of motion. Three statements describing the relations between the forces acting on a body and the motion of the body, first formulated by English physicist and mathematician Isaac Newton, which are the foundation of classical mechanics. So friends, the Newton's first law is Newton's first law, the law of inertia, Newton's law of motion. Newton's first law states that if a body is at rest or moving at a constant period in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. So, in fact, in classical Newtonian mechanics, there is no important distinction between rest and uniform motion in a straight line. They may be regarded as the same state of motion seen by different observers, one moving at the same velocity as the particle and the other moving at constant velocity with respect to the particle. This postulate is known as the law of inertia. So the Newton's second law is F is equals to ma, that is equals to force is equals to mass into acceleration. So Newton's second law states that Newton's second law is a quantitative description of the changes that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction to force imposed on it. The momentum of a body is equal to the magnitude and direction. A force applied to a body can change the magnitude of the momentum or its direction or both. So Newton's second law is one of the most important in all of physics. For a body whose mass m is constant, it can be written as in the form of m equals to F equals to m into a, where F means force and a means acceleration, are both vector quantities. These both are vector quantities. If a body has a net force acting on it, it is accelerated in accordance with the equation. Conversely, if a body is not accelerated, there is no net force acting on it. The Newton's third law, the law of action and reaction. Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law is also known as the law of action and reaction. This law is important in analyzing problems of static equilibrium, where all forces are balanced, but it also applies to bodies in uniform or accelerated motion. The forces it describes are real ones, not mere bookkeeping devices. For example, a book resting on a table applies a downward force equal to its weight on the table. According to the third law, the table applies an equal and opposite force to the book. This force occurs because the weight of the book causes the table to deform slightly so that it pushes back on the book like a coiled spring. If a body has a net force acting on it, it undergoes accelerated motion in accordance with the second law. If there is no net force acting on a body, either because there are no forces at all or because all forces are precisely balanced by contrary forces, the body does not accelerate and may be said to in equilibrium. Conversely, a body that is observed not to be accelerated may be detected to have no net force acting on it. So friends, these are the three laws of Newton. I hope you liked the video. If you like the video, please share and subscribe to the channel. Thank you so much for watching. Have a nice day.